Welcome to this educational video where we'll explore a proposed theoretical physics concept, the unified frequency model of mass and fundamental forces. Note that this is a speculative proposal and not part of mainstream physics, but we'll examine its mathematical framework and conceptual ideas. The core concept of this proposal is that mass and fundamental forces might be unified through a frequency-based framework. The key idea is to reinterpret mass not as an intrinsic property of matter, but as an emergent phenomenon arising from the dynamic interactions of charged particles within a plasma-like universe. In this view, the universe is fundamentally a plasma-like medium where continuous interactions of charged entities give rise to the observable structures and forces. A key analogy in this model compares energy thresholds in atomic plasmas to the QCD mass gap in particle physics. In a hydrogen plasma, electrons transition between energy levels only when they receive enough energy to overcome specific thresholds. For example, the Lyman alpha transition requires a minimum energy of 10.2 electron volts for a photon to be emitted. Similarly, in quantum chromodynamics, or QCD, the theory of the strong nuclear force, there exists a mass gap where the strong force only manifests above certain energy thresholds. This proposal suggests that both phenomena reflect a common principle: the emergence of discrete structures only above well-defined energy thresholds. The core mathematical formulation of this proposal is the unified frequency equation, or MUFE. The equation is expressed as f of omega equals lambda divided by r squared times x times y times f of omega threshold over omega. Here, x and y represent interacting quantities, such as charges for electromagnetism or mass equivalent frequencies for gravity. R is the distance between interacting entities. F of x is a threshold function, specifically a Heaviside step function, that ensures the force only manifests above certain characteristic frequencies. For electromagnetic interactions, the threshold frequency is omega e. For gravitational interactions, it's omega g. And for strong force interactions, it's related to the QCD mass gap. Let's examine the key frequencies and the universal scaling parameter in this model. The electron rest mass frequency, omega e, is derived from the electron's rest energy using the Planck-Einstein relation. It's approximately 4.13 times 10 to the 16th per second. The gravitational frequency, omega g, is related to omega e by the ratio of Coulomb's constant to Newton's gravitational constant. It's approximately 4.8 times 10 to the 26th per second. The QCD mass gap frequency is derived from the pion mass scale, which is approximately 2.05 times 10 to the 23rd per second. The universal scaling parameter lambda links these frequencies and can be calculated using either electromagnetic or gravitational constants. It's approximately 1.53 times 10 to the 43rd in appropriate units. One of the claimed strengths of this model is its ability to recover known force laws using the single universal formulation. When omega equals omega e, the electromagnetic frequency, the force equation becomes F equals lambda times E squared divided by omega E squared, R squared, which simplifies to Coulomb's law. F equals K E times E squared divided by R squared. When omega equals omega g, the gravitational frequency, the force equation becomes F equals lambda times m squared divided by omega g squared, R squared, which simplifies to Newton's law of gravitation. F equals g times m squared divided by R squared. When omega is below the QCD threshold frequency, the threshold function causes the force to vanish, conceptually similar to the confinement property of the strong force below the QCD mass gap. Finally, let's consider some potential implications and critiques of this model. If valid, this approach would offer a new way to understand the nature of mass and the unification of fundamental forces through a common frequency-based framework. However, critical analysis is essential. This proposal would need to explain how massless particles like photons fit into a framework where mass is defined as an emergent property of charge interactions, address quantum phenomena such as entanglement and wave-particle duality. Most importantly, reconcile with the extraordinarily successful and experimentally verified theories of the Standard Model and general relativity. All scientific proposals, especially those challenging mainstream theories, require rigorous mathematical development, making testable predictions, and undergoing extensive peer review and experimental verification. In conclusion, We've explored the unified frequency model, a speculative theoretical proposal that aims to reinterpret mass and fundamental forces through a frequency-based framework. The model introduces a reinterpretation of mass as an emergent property of charge interactions, an analogy between plasma energy thresholds and the QCD mass gap, a unified mathematical framework with a single universal parameter, a threshold function that recovers known force laws whether or not this specific proposal gains traction. The pursuit of unified theories remains a cornerstone of theoretical physics, driving our understanding of the universe forward through rigorous mathematical formulation and experimental verification.